Here we have a SAT math problem. Okay, let's go to the question. The concentration of a chemical compound is equal to the amount of the substance in the container in moles divided by the volume of the solution in cubic centimeters. A chemist has two containers of different sizes filled to the brim with solution, each in the shape of a cube. The edge length of the larger container is 4 times the edge length of the smaller container. Each cube contains 144 moles of a substance. The concentration of the compound in the larger container is 3 moles per cubic centimeter. What is the positive difference between the larger container's volume and the smaller container's volume in cubic centimeters? Okay, now let's consider the first piece of information we have here. That is, the concentration of a chemical compound is equal to the amount of the substance in the container in moles divided by the volume of the solution in cubic centimeters. Okay, let me say that C represents the concentration of a chemical compound that is equal to amount of the substance in the container in moles, that is number of moles. Let me say this N represents the number of moles divided by the volume of the solution in cubic centimeters, that is let's say V represents the volume of the solution in cubic centimeters. Okay, here we got a formula from the first piece of information. Okay, according to the question, we have to find the positive difference between the larger container's volume and the smaller container's volume in cubic centimeters. Since the question is about the volume of the containers, we have to solve for V in this equation. Okay, when I solve for V in this equation, I am getting V equals to N over C. Okay, now we have to get the volumes of the two containers so that we can get the positive difference between the volume of the larger container and volume of the smaller container. For that, we can consider the information we have over here. That is, the chemist has two containers of different sizes, each in the shape of a cube. Okay, now let me draw two containers. Here I have drawn two containers. So this is a smaller one and this is a larger one. Each one is in the shape of a cube. Now let's consider this information. The edge length of the larger container is 4 times the edge length of the smaller container. Okay, now let me assume X as the edge length of the smaller container. Then the edge length of the larger container is 4 times of this, that is 4x. Okay, now let's get a volume of this smaller container. Since it's a cube, to get a volume of this container, what we have to do is we have to raise the edge length to the power of 3, then we get x to the third power. So x cube is the volume of the smaller container. Now to get the volume of the larger container, what we have to do is we have to do the same thing. That is, the edge length has to be raised to the power of 3. That is, 4x has to be raised to the power of 3. So here 4 and x are multiplied and we have the exponent 3 in common. Now what we can do is we can take this exponent 3 separately for each value and multiply the results. Then I'm getting 4 to the third power times x to the third power. The value of 4 cube is 64, that is 64x cube. Okay, here I got the volume of the smaller container, that is x cube. Volume of the larger container is 64x cube. Okay, now we can consider this particular piece of information. Each cube contains 144 moles of a substance. That is, this one contains 144 moles. We know that N represents the number of moles in each container, and this one also we have 144 moles. And the concentration of the compound in the larger container is 3 moles per cubic centimeters. So in the larger container, the concentration is 3 moles per cubic centimeter. Okay, so for the larger container, we have both the values of N and C. So using this formula, we can get the volume of the larger container. Okay, now let me do that over here. That is, the volume of larger container equals to, the formula is N over C, and for N we have 144 and for C we have 3. When I divide them, I am getting 48. Okay, here I got the volume of the larger container, that is 48 cubic centimeters. Already we got the volume of the larger container, that is 64x cube. We can plug in this 64x cube for the volume over here. Then we get 64x cube equals to 48. Now let me divide both sides of this equation by 64 to solve for x cube. The 64 will cancel out. I am getting x cube on the left side. On the right side, when I divide this 48 by 64, I am getting 0.75. This x cube represents the volume of the smaller container. Therefore, the volume of the smaller container is 0.75 cubic centimeters. Okay, now I got the volumes of both the containers. The volume of the larger container is 48 cubic centimeters and the volume of the smaller container is 0.75 cubic centimeters. But our aim is to get the positive difference between the volume of a larger container and the volume of smaller container. To get the positive difference, we have to subtract the volume of the smaller container from the volume of the larger container. We know that the volume of the larger container is 48 and the volume of the smaller container is 0.75. When I simplify this one, I am getting 47.25. Therefore, the positive difference between the larger container's volume and the smaller container's volume is 47.25 cubic centimeter.